Hi everyone, this is Mr. Jerry Pinter, your instructor for EE330 Electronic Circuits. In this video, I will introduce myself and the course. I would normally do this in person, but due to these circumstances, we'll do it this way instead. Please sit back and enjoy this welcome video. Let me just give you a brief introduction again and tell you just a little bit about myself. I'm an electrical engineer like most of you. I did my undergraduate work at the University of Illinois, and I went to grad school at UC San Diego. I spent 17 years in the semiconductor industry working on research, development, and manufacturing of semiconductor integrated circuits. I worked here locally at the Hughes Technology Center in Carlsbad, which was a defense contractor. And then I went to AMCC, Applied Microcircuits Corporation in San Diego, which was a telecommunications company. I retired in 2002, and for the last 20 years, actually this is now 21 years, I've been here at Cal State San Marcos teaching physics, astronomy, and happily, lately, I've been teaching electrical engineering. The picture that you see there is one of the many telescopes that I've built, and I used to use that for my astronomy classes as well. So let's start by going over just a few highlights from the syllabus. The entire syllabus is found on Canvas, so I encourage you to look there for all the details in the syllabus. Speaking of Canvas, that is of course where all of our course information is, lecture notes, the syllabus, homework, labs, and the schedule. One thing I would like to point out is that I have posted complete comprehensive lecture notes on Canvas. This will allow you to come to lecture and not have to write down everything that I'm talking about and everything that I'm showing up on the screen, because there's a lot of information and you would just be nose down and trying to scramble to write down all the notes, and you would miss the essence of the lecture. So the lecture notes are posted there so that you can that you have those available. You can go back and look at those to review and so forth, and that way you can be more engaged, hopefully, in the lecture. This is my email address, which I think you probably are already aware of, but that's the best way to get a hold of me. We will have a lab assistant. I don't know who that individual is yet, but we usually have someone that helps us in the lab, and that's a really nice resource to have since we have a fairly large class size. My office hours will be after class. Actually, this needs to be updated. I will stick around after class at 11:30 basically, and that's the best time if you want to talk to me in person. When you're done with the lab or whatever, you can see me and we can just stay right in the class. That has been very convenient and has worked out well in the past. The textbook. So the textbook that we're using is a classic textbook called Microelectronic Circuits by Cedar and Smith. It's currently in its probably 9th or 10th edition. We're officially using the 8th edition. I should just mention that way back when I was an undergrad in electrical engineering like yourselves, I used the first edition of this textbook at the University of Illinois, and that was in the 1980s, the early 1980s, which is ancient history now. But I just wanted to point out that this textbook has endured. It's a classic. It's used by all the major universities in their electrical engineering program, and that's why we're using it as well. Now, the cost of a new textbook is extremely expensive. I think they're currently more than $200 if you were to buy a new one in the bookstore or on Amazon. You don't need to do that. I would recommend finding a used older edition, and that will be perfectly fine for this course. For example, I have an older 5th edition that I got for about $8 on Amazon, and you'll have to look around to find deals and so forth, but it is very possible to find older used textbooks for under $10, and that will be perfect for this course. We're not going to be doing problems out of the textbook, so it doesn't really matter what edition you have. So the course description, we're going to be studying the properties and physics of semiconductor materials and devices. And the devices that we're going to be looking at are diodes, bipolar junction transistors, or BJTs, and field effect transistors, in particular the MOSFET and the JFET. So we will be covering design, analysis, and simulation of diode and transistor analog electronic circuits, including amplifiers. So notice this is an analog circuit class, not a digital circuit class. And then, of course, we have a laboratory, and the activities will provide hands-on experience with all of the lecture topics. For example, building, measuring, simulating, testing, debugging, all of the electronic devices and circuits. I'm assuming you've all taken or are currently taking EE280. That's the introductory circuit analysis class. That's absolutely necessary in order to do well in this course. So the style of the course and the methodology that how we're going to approach this is to begin by learning the fundamental properties and physics of semiconductor materials. And we're going to focus on silicon since that's the most important semiconductor material. So we will first learn the physics of solid-state semiconductor devices. Again, those devices are the diode, the bipolar junction transistor, the field effect transistors, the MOSFET and the JFET. And once we study the device physics of each of these devices, we will develop device models, which are basically mathematical equations that describe the device's behavior, for example, the current voltage behavior of a particular device. And we'll be looking at different regions of operation, the DC, direct current region, AC small signal, and then at the end of the course, we'll spend some time looking at high frequency models for all of these devices and circuits. So once we sort of learn how a device works, we start working on the circuits, and it's a sort of a three-prong strategy here. The first thing we're going to always do is predict the circuit behavior using the models and the theory. So these are hand calculations where we actually apply the device models and predict what the circuit's going to do. Then we're going to simulate the circuit using computer simulation software called LT-SPICE. And then finally, and arguably the most important one, is we're actually going to measure the circuit in the lab with hands-on measurements. So these steps here we will repeat over and over for each of the devices up here as we go through the semester. This is a weekly course schedule. I won't read through it in detail, but basically this is showing the 15 weeks of the semester here, and these are the topics that we're going to go through, and the chapter from the textbook. And again, this is the 8th edition chapter. It could be slightly different. If you get an earlier edition of the textbook, just be careful. Some of these chapter numbers may have changed over the years. But we're basically covering about 7 of the chapters in the textbook, and we're not particularly going in order. We're going to skip around a little bit, which makes more sense for this course. Course grading, there are 4 different components to the course, and they are equally weighted, and those components are homework, laboratory activities and reports, a midterm exam, and a final exam. And all of these are explained in more details in the syllabus. So this is the daily schedule that we're going to be using this semester, and this schedule is found in the syllabus, and it's also found in Canvas. And basically, it's pretty self-explanatory. This shows the 29 days that will be in class. The day of the week is either Monday or Wednesday, of course, and this is the date. And I have the book chapters so you can follow along with the reading in the textbook. And then this column here is the lecture topic. And this column here, the last column, is the laboratory topic. And one thing you'll notice that I'll explain a little bit more is that on every day, whether it's Monday or Wednesday, we will have lecture and we will have lab. So that's a little different than your schedule shows. I will explain that on the next slide. The other thing I'll just notice or make a note of here is spring break is shown here. We have a holiday here with no class, and then there's the midterm exam is on this date, and then finally I have the final down here. So this explains our daily schedule and how we will break out the day. And this is different than what you see on your official Cal State schedule, which shows that on Monday you have lecture and on Wednesday you have lab. We're going to do it a little bit differently. We will meet every Monday and Wednesday from the 8:30 in the morning till 11:20, as your schedule shows. What's different is that on each day that we meet, we are going to do both lecture and lab. And the reason for this is pretty important. Having a 3-hour lecture is extremely difficult for not only me, the instructor, but especially for you guys, the students. Trying to absorb and assimilate material, for 3 hours is basically impossible. That your eyes would be spinning and my voice would be hoarse and it would just be a nightmare. So what I've done is we're going to break up each session and we're going to lecture. I will lecture for about an hour, hour and a half. It'll depend on the length of the lecture, but that'll be the first half roughly of each session. After that, we'll take a short break, probably, somewhere around 9:45. The break might be as late as 10:30, again, depending on the lecture. But this will allow you to get up and go outside, use the bathroom, get something to eat, drink, and so forth, kind of refresh reset our minds and so forth. And then we will come back in and we will work on laboratory activities for the second half of the session, which officially ends at 11:20. One of the things that you're going to learn in here is the LT Spice simulation software. And I think maybe you've already had an introduction to this in EE280. I'm not really sure. I'm going to assume that you've never seen LT Spice before and just start from the basics and build on that. If you've already used LT Spice, that's great. It'll just be easier for you to pick it up and learn some of the more advanced techniques. So LT Spice is an acronym for Linear Technologies Simulation Program with Integrated Circuit Emphasis. It was software designed by originally Analog Devices, which is now called Linear Technologies. And this is open source freeware. It was originally developed back at Cal Berkeley in the 1970s. So it has been around for a long time, almost 50 years now. It's pretty much an industry standard. All electrical engineers use LT Spice or have used it at some point in their career or school. So we have LT Spice loaded on our Dell laptops that are in the classroom. So they will be available, for when we're using LT Spice during our lab sessions and so forth. I highly recommend, though, that you download LT Spice at home on your computer. And you can Google LT Spice download and get it directly from the source company. It's freeware. It doesn't cost anything. If you are running a PC, it runs great because it was sort of designed for a PC. If you use a Mac, I'm not a Mac guy myself, but a lot of the students are. There are a few bugs and quirks with Mac, with running LT Spice on Macs, but the students seem to figure that out, and you can ask each other for some help on that if you need it. But anyway, yes, I would highly recommend you get LT Spice on your home computer. It's good to use for even checking your homework solutions and things like that. It's just a very handy circuit simulation software to use. So one of the important portions of this course, of course, is the laboratory, and so we have a requirement that you know how to use the equipment in the lab, and so it's assumed that you've been trained and learned how to use this equipment in EE280. We're using obviously the same laboratory, the same set of equipment. So if you took 280 here at Cal State San Marcos, you should be fine. But however, we're asking that all students come in and attend an open lab session for training verification and get signed off. And this will occur during the first 2 weeks of the class. So once we have an open lab schedule, you can come in and it should just take a few minutes to get checked off on the equipment. And if you're rusty on the equipment, don't feel ashamed or anything. That's why our instructing assistants are there to help you. They will refresh your memory, and the goal here is just to make sure that, going into the first lab, you know how to use all the equipment so that you won't damage any of the equipment, and also you want to make sure you obviously get good measurements and so forth. So again, you'll come in on your own time during the open lab sessions, and meet with one of the lab assistants, and they will step you through a process to get checked off for the lab equipment. This is a list of the equipment that we're going to use. Again, this is all the same equipment that you used in 280. One of the really nice features of this class is that we have an open lab schedule which is available, and we'll have some student assistants. Again, I don't know who those students are yet, but we will identify them shortly. And the lab assistants will basically offer and host a weekly open lab sessions. We will have probably two of those every week. And so we'll have the schedule for that as the semester gets going, but it'll be on 2 different days of the week, and we will post the times as well. So the idea is that you can come into Open Lab to complete any unfinished lab activities and or make up missed lab sessions due to illness or travel, etc. Every lab must be completed in this class. So if you miss one because you were sick or you had to travel for whatever reason, that's not a problem, because you can always come in during open lab and work on the missed lab. We'll also be using Open Lab to verify training on our lab equipment, and in the past we've also taught the students how to solder, which is a really nice skill to learn how to use. So stay tuned for more information on our Open Lab schedule. We'll have that available shortly. One of the other highly recommended things for the laboratory part is to get a lab notebook. So just a spiral notebook is usually sufficient. One with graph paper in it is even better, so you can sketch graphs and so forth. But make sure you bring a pencil with an eraser to lab every day. And the lab notebook's an important tool, and you can use it to document your lab experiments, your data analysis, your results, and your conclusions. It'll help you write your more formal lab report, which you're going to hand in. So on Canvas, I posted a document called Lab Notebook Guidelines. It's got 10 tips for a good lab notebook. One note here is that I do not collect or inspect or grade your lab notebook. It's for your own personal use, and I would just highly recommend getting used to using a lab notebook. You'll be using one almost certainly when you're in the industry working as an engineer. So it's a good habit to get into now to document all of your work and experiments. Speaking of the lab reports and so forth, one of the other kind of neat features of this class is that you're going to be writing and submitting your lab reports in IEEE format. And IEEE format's an industry standard way to publish papers. And so your lab reports are going to look very professional, just like something you would see in a journal, in a scientific engineering journal. So on Canvas, there is an IEEE template in Word, and you can download and make a copy of that template and then just edit it. Just change all the words and the diagrams and so forth. So this will be, if you've never used IEEE format before, there's always a learning curve with something like this. It's very picky, the rules and so forth. You'll read that on the template, what the rules are for figures, and there's an abstract and things like that. But as we go through the semester, your lab reports will get better and better, because you'll get more and more used to this type of format. Also, make sure you bring a USB flash drive, a thumb drive to class. Any capacity is good, even a 16 gigabit capacity, which you can get for about $7 on Amazon. So you probably already have one of these, but you'll absolutely need it. Bring it with you to class. You can leave it in your lab kit, but you probably want to take it home with you, because you're going to be using it to capture screenshots from the oscilloscope, from LT Spice schematics and so forth. And you're going to use those screenshots and put them into your lab reports. That's you're going to put them on this thumb drive. So make sure you get one of those. Last slide here, just let me go real quickly through some laboratory guidelines. So attendance is mandatory. So that means you need to be in class every day on Monday and Wednesday, because remember, we have lab every day on Monday and Wednesday. So if you miss a session, which sometimes happens, right? You get sick or you have to go on travel or whatever, you have to make it up during one of the open lab sessions that we talked about. Now, one of the great benefits of this program here at Cal State San Marcos is that our laboratory is equipped with over 30 stations. So we have enough lab stations so that each of you can work at your own lab station. So you're going to have your own set of equipment to use. You won't have to share it. And this is really important because it forces you to learn how to use the equipment on your own and do all the debugging and so forth. So it'll really sort of empower you to be in control of your own work. However, I would like to encourage sort of a culture of collaboration and cooperation amongst students and instructors. So you're encouraged to ask other students and or instructors for any help, assistance, or questions and so forth. So please feel free to compare and discuss your results with others. You don't have to just sit in your seat. You can get up and move around the classroom. Go ask your buddy on the other side of the classroom what their results look like, especially if something looks strange. And you can work together to solve problems and so forth. So this is, it makes for a nice sort of informal atmosphere, and this will, give you a greater chance of success, and it'll keep the morale in the class higher with this type of culture. So professional conduct is expected. You've heard all this before, but no cell phones, headphones, texting, social media, etc. during lecture and lab. No food or drink on the lab tables. This is a safety issue. Obviously, we have electrical equipment. So keep water bottles on the floor, and you can eat outside during break. I will be doing the same thing when we take a break during class every day. Also, you'll be given a lab manual. We'll distribute those the first week in class or maybe the second week. Bring it to class every day. It's yours to keep. You don't have to pay for it, but don't lose it. If you do lose it, you'll have to print out your own copies from Canvas. The lab manual is in electronic form as well on Canvas. So that is it for this, you guys. Thank you for your patience. And again, I'm sorry we're not doing this in person, but I will get back to class as soon as I can, and I look forward to meeting you there. Take care. Goodbye.